Hello everyone, I hope you all are doing very well. Here in this session, we are going to cover about BFS Traversal on tree. We are going to take first the scenario that what is BFS Traversal, how it performs, what are their real-time applications, why it is used, and thereafter we are going to use the concept of Python classes to learn that how BFS traversal would be done to searching any particular key. So it is very important concept. I hope at the end of this video you all are going to learn very complete concept of this important traversal technique, right? So let's start. Basically, BFS, it is an abbreviation for breadth first search. It is one kind of, you can say that a traversal algorithm that can be used for tree traversal as well as that can be used for graph traversal, right? It begins from the root node, that also called as a tree root, and it also called somewhat as a parent node, but it is uppermost parent node, as you can see, right? Some arbitrary node of a graph, or sometimes referred as a search key. And it explores the neighbor nodes first before moving to the next level. So it works on level to level. And before moving to next level, it must discover all its level based nodes first. Thereafter, it will go to the next level. So let's say if a particular node is at level 0 and if it is moving to level 1, then first it will discover all the nodes at level 1 and thereafter it will move to level 2, likewise that. Okay, so this is very basic, very scratch point of view of breadth first search. Now let's come to the algorithm, that how its algorithm works. So basically you know that BFS is a technique that uses queue as a data structure. The important property of queue, that is first come first server, or first in first out. FIFO property is there. So whichever node will come first, we are going to explore the neighbor nodes of that particular node first, and thereafter we are going to explore the remaining nodes, right? So create a queue, add the root node into it, take front item of the queue and removes it from the queue. Third step is, if the removed item has left child, add it to the queue, and if the removed item has right child, add it to the queue, and repeat the process until the queue is empty. So basically, let me try to explain these 5 points with the help of a short example. Let's say this is a tree. Let's say this is node number 1, node number 2, node number 3, node number 5, and let's say it is node number 4, and let's say node number 5, and let's say it is node number 6, node number 7, and let's say further node number 8 and node number 9. Likewise that some tree, you can assume it as some kind of tree. So what basically is going to happen in breakfast search traversal, we are going to start from this node. This is also called as a root node, and sometimes we also call it as a search tree. In terms of graph, we can begin our traversal from this search key, right? So from node 1 we are going to start. So there would be a queue, and this queue will work on the basis of first come first serve basis, right? So node 1 is here. Now what I need to do, I need to just first push it. I just need to enqueue it. The enqueue term is correct in terms of queue, and I need to dequeue it because it is a root node. So I need to dequeue it. But after just dequeuing it, I need to mention all its neighboring elements. So root 1 is having neighboring elements 2 and 3. So I am going to enqueue root number 2 and root number 3. So whichever root will come first, we need to dequeue it first. So right now we have only node number 1, root node only having 2 nodes. So we have to finish it up to here for root node 1. So first it should be 1. Thereafter we are going to focus on the node which is come just after it. So after it we have taken node number 2. So I need to dequeue it. And just after dequeuing, I need to put, or you can say that we need to mention all its neighboring nodes first, and thereafter we can remove it. Thereafter we can dequeue it. So what is the neighboring nodes of root number 2, node number 2? 4 and 5. So I need to put 4, I need to put 5. It means that I am just enqueuing these elements. which is neighboring of this particular node. After that, I think I have covered all the neighboring elements of root 2, that is 4 and 5. So what we need to do, we need to dequeue it. So we have dequeued it. In queue, you can see that the next element is 3. So I need to focus on this element, on this node 3. And what I need to do, I need to mention all the neighboring elements of root 3 also. So you can see that root number 3 is having root number 6 and root number 7 as its neighboring nodes. So I need to put 6 and 7. I am just inqueuing it. So let me make it fresh up to here. First 1 was there, thereafter 2 was there, thereafter 3 is there. And when 3 is there, I have just added root number 6 and root number 7. And now I am dequeuing 3 because I have covered all the neighboring nodes of 3. After that, after dequeuing this root number 3, what I need to do, I need to focus on root number 4. So node number 4, I need to see, is there any node which is in neighborhood of this 4? That is only 2, which is upper one, but we have already covered it. So we do not have to cover it now. So no neighbor node for 4. So just dequeue it. Thereafter, node number 5. Any neighbor nodes for 5? No. So just dequeue it. After root number 6, any neighbor nodes? No. So just dequeue it. So the order of my dequeuing is 4, then 5, then 6. After that, you can see there is a root number 7. So node number 7 is having two neighbor nodes, 8 and 9. So I need to enqueue 8 first and then 9. And after covering all its neighbor nodes, no further neighbor nodes are there. So just dequeue it and put it in the sequence. Why I am doing so? Because it is first in, first out mechanism. Whoever node will be covered first, we are going to explore the neighbor nodes of that particular node first, right? Thereafter, node number 8, no any element, no any particular neighbor element for it. So just dequeue it. Then 9, no any particular neighbor element for it, right? So this is the thing. So if you can see here, what we have done, we have just covered first element, thereafter 2, then 3, thereafter 4, then 5, then 6, and then 8 and 9. So first, then 2 and 3, then 4, then 5, then 6, then 7, then 8, then 9. That is why it is also called as level order traversal. That is why it is also called as level order traversal. This is how breadth first search technique will be implemented in real time for finding out any particular search key, for finding out whether any particular network is connected or not. And this is how level search technique or breadth first traversal algorithm works, right? What data structure we have used for it? Q as a data structures we need to use it. Now, if you are going to see some real-time application of it, network or social media friend suggestion. So let's say I am a friend and some two more friends are connected to me on my Facebook account, and this friend is associated with some more. So I will get a suggestion that this particular node is having this person in his or her friend list. So you might know him or her. So it will give me some social media friend suggestion. This is nothing. Every account on social media is nothing but it is a node. Every account on social media is nothing but it is a single node. Now let's say this node is connected to this and to this and to this, and this node is connected to this and this. So one mutual suggestion will be there between person A and B, that this person A is connected to two other person which is also in the connection of B. So A and B might know each other. This is the thing. So such kind of network or social media friend suggestion works in real-time applications of BFS traversal, right? Second one is garbage collection. So basically, garbage collection is very important use right now. Let's say if we are using runtime applications and in dynamic timing, some nodes are free. So we need to free up the memory. So in freeing the memory, how to know that which nodes are free? So we are going to perform searching here. All the nodes which are not connected to this tree, it means that they are free nodes. They are not connected nodes. So we can free that particular nodes using BFS traversal, because after applying BFS, we know that which nodes are connected and which nodes are not connected. So we can, the nodes which are not connected into that tree, we can free them up. This is how we can perform garbage collection, right? Shortest path finding. I hope many times we can use routing algorithms in routing algorithms, in vector routing algorithms, or you can say that many times in such kind of networking things are there, right? So to send some packets from one network to other network, they both are on different networks. So shortest single path or shortest path we can find using this algorithm. In web crawling, many particular web pages are there, and if you want to search particular term, particular search, particular word or particular key on particular web page, we can use search key mechanism for doing web crawling very efficiently with the help of BFS algorithm, right? So these are some of the important real-time applications which 100% use BFS techniques for implementation it in a real-time work. Right now we are going to implement it now, and I am going to see you live that how live you are going to code it, how live you are going to see that how BFS traversal works on. So what is our pre-assumptions? That we are going to use class of concept of classes in Python, as it is an object oriented language, and we are going to use class to implement data structure to be used in a program. And we are going to I am going to show you that what kind of tree you need to make, right? So basically this is the data which you need to do. So you need to make a tree like this, in which the electronics, it is a main node, or you can say that it is a root node. Under this root node, one node is freeze, another node is mobile, another node is smart TV. Under smart TV, we further have some more nodes, that is LG smart TV. Under this node, we have further two more nodes, that is 40-inch LG TV and 50-inch LG smart TV. And again, in smart TV, the main node is having Samsung smart TV, Panasonic smart TV, Real smart TV, and Redmi smart TV, right? So let's say we want to find a particular search string, that is 40-inch LG smart TV. So if you're going to see that the 40-inch LG smart TV is here, the highlighted part. So how this algorithm will work? So basically, this algorithm start working from this electronic node, that is a root node, you can say. And this root node is having three nodes: one is a freeze, one is a mobile, and one is a smart TV. So it will enter into a smart TV node. Under this smart TV node, it will enter into LG smart TV node, and under LG smart TV node, it will enter into 40-inch LG smart TV. This is how it is going to perform. I am going to give you how it, I am going to give you the live code also, and I am going to explain each line one by one. Right? Don't worry. So this is how searching mechanism will work. Now it is also going to give us path. This is the first path, that electronics will go into smart TV. Second path, smart TV to LG smart TV, and third path, LG smart TV to 40-inch LG smart TV. Right? This is how. So how now up to here? I hope each and everything is clear. Now, one important questions that can be in your mind, that how to create nodes. So this is the root node. Let's say electronics. Under this electronics root node, if we treat it as a zero, we can treat one root number one as a freeze, root number two as a mobile, node number three as a smart TV. Correct? Under smart TV, we are having node number 4 as a LG smart TV, and node number 5 is a Samsung smart TV, node number 6 is a Panasonic, node number 7 is a Realme, and node number 8 is a Redmi. And under this LG smart TV, we may have one more node, that is node number 9 for 40-inch and node number 10 for 50-inch smart TV. Thereafter mobile. So node number 11, 12, 13, 14, and for this node number 15, 16, 17. In reverse, we are working, right? This is how a tree will be developed. And we need to create these nodes in order to traverse. So what is our technique first? We need to construct this tree first, because in output you need to see this complete output. So first we need to construct the tree. After construction of tree, we need to search this particular element, that is 40-inch smart TV. We need to search this string, and we also need the path of it, that in electronics it will go into smart TV, then LG smart TV, then 40-inch LG smart TV. And what is the cost? That is how much edges will be there from root node to that particular key. These things we have to perform. So let's start. This is a simple piece of code which I am going to run on Google Colab, so it would be better understandable, right? So what I can do, I am sharing my screen now, and with the help of this screen, you can see my Google Colab screen. I hope this Google Colab screen is visible, right? Just let me check whether it is visible or not, right? Yeah, I hope it is visible, correct? So what we can do, let's start from this. So first, I am giving you overall idea of this particular code that we have created for traversing BFS algorithm on particular tree, and we are going to look like the tree, right? So what we need to do, let me explain it first, and thereafter we are going to explain it line by line. So basically this is a Python program that represents a tree data structure, right? This is a Python program that is representing a tree data structure, and the node class, here we have used this node class. Basically it is used to define a node in the tree, and it has several methods for manipulating the node and its children. The tree class is used here, right? If you are going to see, the tree class is used here, they're using it, and it is used to define a tree, and it has methods for inserting new nodes into the tree and for traversing the tree, right? The BFS search function we have used here, if you are going to see this BFS search function we have used here, and basically this function is going to perform a breadth first search on the tree, starting at the root node, and it returns the node with value that matches the search value. Our search value is like 40-inch LGTB, right? That is going to search with the help of this particular function. And thereafter you can see we have created one more function, that is draw path, and this particular function is going to trace the path from the solution node written by the BFS search back to the root node of the tree, and prints the path along with the cost. That what is the cost? That is nothing but the number of edges that going to be counted in that path. And the program also defines a tree. This is the program that we are going to define it node by node. So this program is also going to define tree with several nodes and demonstrates how to search for a particular value in the tree using BFS search function, right? So let's start from this line first, and I am going to explain it line by line. So I hope each and every line should be clearly visible to you. So we are going to first work on this part, that what exactly we are doing here, right? So if you are going to see, we are creating a class node, and this code defines an init method. This class node is defining an init method, as you can see my highlighted part. And basically this method is called when an object is created which is based on class, and it initializes the objects by setting its attributes, right? And in this case the init method, you can see here, takes three arguments. It is taking three arguments, and arguments, you can clearly see that the parent value is here, and you can see that the value is here, and the child list is here, and these arguments are used to set the corresponding attributes of the objects being created. The parent attribute is set to the value of the parent argument, and it is passed to this init method. The value attribute is set to the value of the value argument, which is we are going to pass in the init method, and the child attribute is set to the value of child list argument that is passed in the init method. Basically, just for creation of the tree, parent node would be their value of that particular node, child node number, right? Which we have discussed in the tree part, right? This is the thing. Now, init method, if you are going to see here, self level equals to 0. If you are going to see this particular line, here the level attribute is set to 0. It means that the topmost level is 0. Then if the parent attribute is not none, if the parent attribute is not none, it means that the level attribute is updated to be one more than the level attribute of the parent objects, obviously, right? Now, if you are going to see the next definition, and that is definition of add child node, and two parameters are there, self and child node. So basically this method, if you are going to see, this code defines a method which is child node, add a child node method, right? And this method adds the child node object to the list of the children of the current node objects by appearing it to the child attribute of the current object. For example, if we are having two nodes, let's say node 1 and node 2, and node 1 is the parent of node 2, then calling node 1 dot add child node, right, will add node 2 to the list of its children. That is the meaning of this. So I hope it is clear what I want to say. Thereafter we are having definition of this one more function, space count, right? So this definition, one more function, space count self str parent, if self parent equals to none, str parent equals to str parent, right? So I am going to explain this part now. So let's focus on it, that what exactly this definition is saying, what exactly this function is going to perform, right? This code defines a method called space count. I hope you all know it. This method is used to calculate the number of spaces. This method is going to calculate number of spaces that belongs to be printed before a node when the printing of the tree that the node belongs to. Basically, this method first initializes an empty string that is called as string parent, that is called as string parent, an empty node, and then it checks if the parent attribute of the current node object is none. Correct? Now, if the current node object is none, if it is, then it sets its str parent, it sets its str parent, as you can see here, so to the string none, and enters into the loop that traverses the parent chain of the current node object until it reaches the node with a parent node attribute of none. For each node in the parent chain, what we are doing, the loop appends the value of the node to string parent, which is separated by this particular symbol. That is nothing but that is separated by arrow. And finally, the method returns the length of the string parent plus 1. This value is used as a number of spaces to parent before a node printing. So basically, it is nothing but, if you are going to see, we are talking about this, that how much spaces we need to add here for this particular arrow is there. How many spaces we need to add here, how many spaces we need to add here, how many spaces we need to add here, right? And thereafter, we are just what we are doing, we are printing this arrow. So this is the task of this particular code is doing the task of this particular function space count is doing this, right? Which I have explained as of now. Now, if we are going to see, we are having one more function that is very, very important, REPR itself. And what is this function is going to do? Basically, here, if you are going to see, this is a method which is called as REPR, right? And that is a special method in Python classes. And it is used to specify how the object should be represented as a string. How object should be represented as a string, this part is going to explain, right? And for example, when it is printed or when it is used to be with REPR function. Basically, this method will take one argument self. This is the one argument which we are passing inside this function, that is self. And this particular function that is self, which we are passing it as an argument inside the method REPR. So it will be used to store the string representation of an object. This method first checks if the parent attribute of the object is none. If it is, it sets the string parent to string representation of none. Correct? And thereafter, if the parent attribute is not none, it means that we need to go to the else part. And inside this else part, if the parent attribute is not none, it sets str parent, that is string parent, to the string representation of the value attribute of the parent object. The method then adds a new line character. The methods then add new line character, right? And basically, after adding this new line character and some spaces, and then some space count method on objects. And finally, what this line is going to do, here this method adds the string representation of the object's value attribute, a space, and a string representation of the object's child attribute to str return, right? And then thereafter it is going to return it. Thereafter, one class tree, this tree class we are creating, and this particular function, this particular part, this code defines a class called tree, which represents a tree data structure. And here init, this init method is a special method in a Python class that is used to initialize an object when it is created. It takes two arguments. One is self and other one is root node. Two arguments it is going to take. Correct? Now, if you are going to take two arguments, that is self and root node, self refers to the object itself. and root node reflects node object that will be used as a root of the tree. The method assigns root node as a root attribute. Correct. This method assigns root node as a root attribute, and the left one, right? And if you are going to see this particular node, self dot root equals to root node. So this method assigns root node to the root attribute of the object and the insert node, this insert node function, right? This method is used to insert a new node into the tree. It takes three arguments: self, node value, and parent node. As you can see, three arguments are here. That is self, node value, and parent node. So if you are going to see, self will refer to object itself, as you know. Node value, this node value is basically, right, it node should have, it is a new node that should have, and parent node is the node that will be the parent node of the new node. The method creates new node objects with the node value as its value and parent node as its parent. Correct. After that, this REPR method is there. And this particular method is a special method in Python, I have already told, and it is used to specify how the object should be represented as a string. For example, when it is printed or when it is used with the REPR function, the method returns a string representation of object's root. Correct. After that, very important function, BFS search, binary search function, and crux of the code basically. This code is going to implement a BFS search, that is breadth first search algorithm, to search for a node with a specific value in a tree. This BFS search function basically, it is going to take two arguments, search value and full tree. Two arguments are here, and the value which we are searching for, right, is basically, it is a tree full tree. That is the particular value which we are searching for. So the search value, this search value which we are taking as a first parameter, this search value is a value which we are searching for the tree, in the full tree, and the tree in which we are searching the function begins, this full tree. Correct. This full tree basically, the tree in which we are searching the function, which begins by creating an empty queue. First, I already told, empty queue will be there, and adding the root node to the tree of the queue. It then creates variable solution node. It is thereafter going to create variable solution node that will be used to store the node with the desired value that would be found. Right. After that, the function then enters into a while loop. Thereafter, the function will enter into the while loop, and it will check. After that function is entered into the while loop, it will check that, just a second, here it is a while q temp node equals to q dot pop, right? So after that, it will continue as long as queue is not empty. Here you can see, if temp node dot value equals to search value and temp node equals to q dot pop and search node equals to temp node. So it is going to continue. It is going to continue as long as the queue is not empty. In each iteration of the loop, it is going to remove the first node from the queue, as we have done in BFS technique. Until and unless we are not going to our desired key, it is going to pop up that particular value. Correct. It then checks if the value of temp node is equal to search value. If the value of temp node is equal to search value, in that case, in that particular case, it will check the value that is equal to or not. If it is equal, then it is going to assign temp node value. Then it is going to assign that particular value to temp node value. Correct. And if it is not equal, it is going to add all the children of temp node to the end of the queue using q.extend method. If it is not equal, it is going to do what? It is going to add all the children of temp node at the end of queue using q.extend. After this loop is going to end, after this while loop is going to end, this function is going to return the value of solution node. If the search value was not found in the tree, solution node would be none dot diff, right? So if it is not going to be there, then it is going to return none. If it is found, in that case, it is also going to draw the path. So if it is found, then it is going to draw the path. For this, we have written this function draw path solve node list one equals to like this, right? So what this particular code is going to do, this code appears to be a function that takes a node as a tree, as an argument, and then prints the path from the root to the tree, particular for that particular path. This function begins by creating an empty list, which is called as list1, right? It is going to begin from empty list by creating empty list, which is going to be seen like this, list1, right? And initializes a variable temp node to the value of the input node sol node, correct? After that, after that, it then enters into the loop that continues as long as temp node is not null. Until and unless this while loop is true, means temp node is not null, this method is going to run. And when the loop will break, when this particular loop is going to break, when this particular loop is going to end, this function is going to reverse. This function is going to do what? It is going to reverse the order of element in list 1, correct? And then it is going to print the path. Then it is going to print the path by printing each element, in the list, which is separated by this particular arrow symbol. It also print this path is, it is also going to print the cost of the path by printing the length of list -1, because we are starting from 0. And this is what we have do. This is how we are creating the nodes. Tree 1 equals to tree node electronics. It is our root node. Then child 1 is this, that is freeze. Then child 15, 16, 17, 2. So I hope this is clear what we have done. Na? This is child node 0, child node 1, 2, 3. So this part we are doing here. Different childrens we have created. So this particular part is nothing but creating child node into that particular tree. I have already told you that first child node will be what? First root node is what? Electronics. First child node is fridge. Second child node is mobile. And third child node is smart TV. As you can see clearly here. First is fridge. Second is mobile. Third one is smart TV. Fourth one will be LG smart TV. Correct? And fifth one would be Samsung smart TV. Sixth one would be Panasonic smart TV. Likewise this. So I hope it is clear. So this is simple creation of tree, which I have already explained in the earlier part of this video. And thereafter we are just printing this tree, which you are going to see as output. And we are printing the tree one. Search string is, if you want to search this particular 40-inch LG smart TV, we can search it using this keyword search underscore string, and we can print it. Print search string is equals to underscore double quote plus search string, because this particular value is taking this particular string that we want to search. And this is going to work on BFS search. Here this BFS search function is calling. So this function is going to call, which we have discussed in detail, right? And after this function is going to do, if sol node is none, it is going to return string not found. If it is found, it is going to return the solution, that this is the tree and this is the path and this is the cost of path. And you can see here, this is the exact output that we want. This is the exact output that we want. If you want to run it again, you can just run it and you can see the output. After running this code, you can see the output that we are desiring of. So let me do the screen reset so that you can see the complete output at once. It might take some few seconds for appearing the output. Our desirable output was this, right? And search string would be like this, path we needed, and we also need cost of path. So this is our desirable output. Each and everything which is in our desire, we have just discussed here, and this is the exact output that we want. This is BFS, breadth first search technique. Here we have used the concept of classes in Python, and we have used the concept of methods inside the functions. We have used the concept of arguments as a parameters and arguments. We have also been used the very important concept of how classes are going to be work inside Python using concept. So this the very basic concepts of Python. We have learned here a very important concept, that is BFS Traversal. I hope each and everything is very crystal clear to all of you. Further, if anybody have any kind of doubt or confusion or query, feel free to ask, comment in the comment box. I will try to resolve them as early as possible. Thank you so much, guys. Have a very nice day. Jai Hind, Jai Bharat.